Hi, welcome back. In our previous lesson, we started with a practice question on income and substitution effect. Today, we'll be moving on to part 2. So our task here today is to split the total effect of a price change into income and substitution effect. What we know so far is this. We know that the original price of good X and good Y is equal to 1. And the original income is equal to 8. Given this price and this income, and given the utility function, the original budget line is B1, the original bundle is E1, and the original indifference curve is U1. We've solved in our previous lesson that with this information, the quantity demand of good X is 4 units, which is represented here as X1, and the quantity demand of good Y is also 4 units, which is represented here. Now, the price of good X increased from 1 to 2, which is represented as PX prime. With this increase in price, our consumer named Ella moved from budget constraint B1 to budget constraint B2, moving her to a new equilibrium bundle E2 and indifference curve U2. At her new equilibrium bundle, the quantity demand of good X reduced to 2. So we note this as X2 being equal to 2 units. The total effect of the increase in the price of good X is 2, which is the new demand minus old demand, which is minus 2. So the minus simply means that an increase in price has reduced the demand of the good. We've noted in our previous lessons that with this total effect, the substitution effect is always the difference between XC and X1 represented in a diagram, or EC and E1. If we look at our diagram, between X1 and XC is our substitution effect, and then the rest is our income effect between XC and then X2. But then the difference between X2 and X1 is the total effect. Previously, we saw that the income that is needed to keep Ella at her original utility 1, even though the prices have changed, is a new income of 11.3, where we saw that the difference between the old and the new income, which is C, is equal to 2.3. The next question we are going to be considering here is to calculate the change in demand for good X due to the income effect and the substitution effect. At this new income, our quantity demand of good X, if we represent this as XC, is going to be the new income divided by 2 and then the new price. So this is 11.3 divided by 2. So this is 2.83 units. Our XC is 2.83 units. We have said that the difference between XC and X1 is our substitution effect. So we know X1 to be equal to 4 units. And now we know XC to be equal to 2.83. So the difference, which is our substitution effect, is equal to minus 1.17 units. So the change in the demand due to substitution effect is 1.17. And then the negative simply means that substitution effect is negative, which is an increase in price, a decrease in the quantity demand. So that we know that the rest of the effect is going to be income effect. So let's look at our income effect. Our income effect is the difference between X2 and XC. So we know that the new demand, which is X2, is 2 units, and then XC we calculated as 2.83. So this simply means that the difference due to income effect is minus 0.83 units. Now, to confirm that this calculation is correct, we know that total effect is equal to minus 2, which is 2 minus 4. So this is 1 and this is X2. And we know that this minus 2 can be decomposed into substitution effect plus income effect. Now, we've calculated our substitution effect as minus 1.17. Then our income effect is also minus 0.83. So if you combine these two, it's going to be minus 2. So since both the substitution effect and the income effect are negative, it means this good is a normal good. This is all that we have looking at practical questions on income and substitution effect. Our next lesson is going to be on Hicksian versus Slawski decomposition of income and substitution effect. If you enjoyed today's lesson, consider subscribing. Thank you.